Kia ora. We're continuing with Walkermaths 2.12 probability methods, and we are starting at page 23, and I'm just going to burn through as many of these questions as I can as walkthroughs. Okay, the distances jumped in a school long jump competition have a mean of 170 centimeters. As soon as I see that mean of 170, I'm just going to draw it in. 170, I might even put a little mu there. Okay, with a standard deviation of 15. Perfect. That's the other piece of information I want. Standard deviation equals 15. Calculate the probability that a student jumped less than 200 centimeters. So sometimes it's good to write a probability statement. Probability that the random variable x, that's this thing, is less than, so that's this symbol, less than 200. So that's the probability we're looking for. So where would 200 be on here? That would be above 170, and it's about 2 standard deviations away, so it's probably around about there. This doesn't matter too much. So our x value is x equals 200. Okay, and we want to know everything less than that, so we can shade that in like this. So then if we're using our tables, all I like to do is draw another similarly shaped normal distribution below, and this is z, right? And if we want to transform our x value to a z value, it will be directly below. And if we want to find z, we're going to have to use our formula, and our formula is that z equals x minus mu over sigma. Now I'm going to move this over a bit and just bring up the table, just because I want to show you what you get in the exam. So you get given this in the exam anyway. So see how in this it actually has the formula all ready to go for you. That's exactly that. So you can just use that. You don't have to memorize this or anything. Okay, so our x value is 200, our mean is 170, and our standard deviation is 15. So that means that little z is going to be 30 over 15, and that is 2. Okay, let me just readjust my camera a little bit for you guys. Okay, cool. So our z value is 2. I kind of like to think of it as 2.000, right? Because they can be up to 3 dp long, and we're able to find them in these probability standard normal distribution tables. Okay, so our table helps us find between 0 and z. So we can find this area here using our table. So let's do that. So we're looking for 2.000, so I just go down to 2.0 and make sure I'm in the 0 column, and there's no difference. So it's just this probability here. So it's 0.4772. Now if that's 0.4772, we can find out everything below that by the fact that this whole distribution is symmetrical. So if the whole distribution covers an area of 1, half of the distribution is going to be half of 1, which is 0.5. Right? So if this that I'm shading diagonally down to the right is equal to 0.5, and that which I've shaded diagonally down to the left is 0.4772, we can find our probability by just adding those two together, because that will be proportional to what's happening in x. So all we need to do is just add those two things, and then we're finished. So it's 0.5 plus 0.4772. So that's going to be 0.9772. The probability that a student jumped less than 200 centimeters. So that's our final answer for page 22. Oh, sorry, page 23. Okay, let's move on. Okay. We are now having a look at probabilities on the right tail of the curve. Now, remember how we worked out this whole area is equal to 1. That means half the area is equal to 0.5. So that means if we know everything in this gray area, so say we can find this probability from the tables because that would be between our 0 and z in the tables, then we're able to use that probability and just do 0.5, which is the total area, and minus off that grey bit, and that will find us the peachy orange bit. Okay, so let's do an example. Blah 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 blah, mean 170. You probably end up getting a little bit lazy and just start writing it like this, so I'll just do it a little bit lazier. Standard deviation of 15. Calculate the probability that a student jumped over 180 centimeters. There's probably a little bit left of this, but I just want to make it as clear as possible. So maybe it is worth labeling, to be honest, because we still are trying to get our head around what these things are. This is our little x, this is our mean, and this is our standard deviation. Once you get your head around what these things are, you can start being a little bit lazy with them. Okay, so see, it's calculate the probability that a student jumped over 180 centimeters, so it's all of the area beyond 180, or probability that the random variable takes a value that is greater than 180. That's what we're looking for. So this is our x. Let's draw in our z. Now, our z value is going to be just below here, and we're going to be able to work it out with that same formula. Let's get it up on the formula sheet. So if we want to find this little z value, all we do is we go z equals the x value, which is 180, minus the mean, which is 170, over the standard deviation, which is 15. So that's going to be 10 over 15. And 10 over 15 is the same as 2 over 3, and as a decimal that's 0.667. Now, notice I stopped at 3 decimal places. That's because the table can only go up to 3 decimal places. This table value is about as hard as it gets when finding them, so let's have a look at it. What we're going to do is we now have our z value that's 0.667 here. And our table, if we look at the picture, it can only find between 0 and z. So our table's only capable of finding this area that I'm shading now. We'll do that. Okay, so 0.6 is here. I'll just highlight the whole thing. Now, 0.66, I'm just going to go down to this one, so it's 0.2454. So 0.2454. But there's this little difference of 7 at the end, so we're just going to find that in the differences column. So here we are, 7, so it's 23 that we've got to add on. So it's 0.0023. So that comes out at a nice number. Well, it's not that nice, to be honest, but it's easy to add up. Okay, so we've found that this shaded area here is 0.2477. But we are actually interested in this bit that I haven't shaded yet. And what I'm going to do is I'm just going to shade it in pencil for you, just so we can explain the logic one more time. So if we want to find the pencil shaded area, I'm going to drag, where's some space on the screen? I'm going to pull it down to here. If we want to find what's left over in pencil, well, what we know is that the total area, which I'm going to do in green, right? We know that this total, not actually total, the half of the normal distribution, which is in green, is 0.5. Now, what we're going to do is we're going to take that 0.5 and minus off what this area was, which is 0.2477. Then that will tell us what's left in the pencil shaded bit, what's left over. So that's going to be 0.2523. Right? So then this now is the probability we were looking for. It's this shaded area up here, 0.2523. Cool. So that means we've got our probability that x is greater than 180. It's 0.2523. Hope that helps.